Alright, welcome. This is like the last part of the limits unit. We're going to be doing day 3 of the notes. This is on page 11. So yesterday when you did the limits for notes, when you went to specific numbers or infinity, you didn't have anything to worry about. You had like expressions there. They weren't fractions or anything. What's going to come up is rational functions. So algebra, when there's fractions involved, and a finite value means an exact number. And we're going to do these with infinite values too. Alright, so when we start with something like this, so we're going, this is the same as yesterday. So find the limit as x approaches 2, and you have this one. Now, it's just in a fraction form, so if you took it and plugged it in, let's see, we'd have 2 minus 3 on the bottom, 5 and 2 cubed plus 4. So 5 times 8, so we got 40 plus 4 over negative 1. Negative 1, so that makes it, so this limit is negative 44. Alright, so that one was not a problem, not a big deal. You plugged it in the same way you always did. Now, there comes a problem though when we have something like example 2, when we plug 2 in and we plug it into the denominator, which means you get 2 minus 2 in the denominator, then you do 2 squared minus 4, so I get 4 minus 4 over 2 minus 2, 0 over 0, which, remember, this means you have a whole. So that means we need to go back and factor first. So if you are ever going to have 0 in the denominator, this means there's going to cause an issue. You need to factor first. So if we factor the top, x squared minus 4, x minus 2, and x plus 2. And the bottom is just x minus 2. We in fact have a whole because we have the canceling out here. Okay, so what this means is you don't need to find the whole, so we don't need to plug it in and say it's at 2 comma 4. What we need to do is just say, okay, now after that idea that I cancel that out and that goes away, I take the limit as x approaches 2, I cancel that stuff out, and now I only have to do it with what's left. So I'm going to take the limit as I'm approaching this, so I'm just plug it in now. Alright, so if that kind of makes sense, if you kind of take a quick look at the next one, letter B, we'd have plug 3 and I'd have 3 minus 3 in the denominator, which doesn't work. So I need to see if I can do something else. So try factoring. If you want to try it and then check, now's a good time to pause. X minus 3 over x minus 3. Now I know this comes up a couple times. Now these are all the same. It doesn't mean you cancel everything out. It's only one parenthesis on top for one parenthesis on bottom, so you're left with just x minus 3. So now really I'm doing the limit as x approaches 3 of just x minus 3. So I plug in, I get 3 minus 3, which is 0. Which is not the same as if I plugged it in right away. Would that, it was, no, when you divide by 0, it's undefined. It's not a 0 value. So we're actually on the graph. As x is approaching 3, my y value is getting close to the 0, so they're getting close to the x-axis. Sorry. Alright, so now the next thing, case 3, to take the limit of a function of an undefined value of x where there are no common factors. So when you look at something like this, this means there's a vertical asymptote. So there's nothing to cancel here. I can't cancel the 2 with the 2 and the x with it. It doesn't work. There's nothing to cancel. So we need to, this means that there's a vertical asymptote at that number. So if I plugged 4 in right away, it would make a 0 in the denominator, make it undefined. So the limit may be infinity, negative infinity, or may not exist. So what you kind of need to do is think about this. if I'm approaching it on this side, so part A, approaching it, x is going towards 4, this is the left side. So it's a one-sided limit. On the next one, this is from the positive side, so on the right side of it. And this I need to look at, what is the left side and right side doing? Okay, so in other words, it's like having a vertical asymptote and saying, is my left side and my right side going towards the same number? Are they going opposite directions? What's going on? All right, so what we do is we kind of take some numbers. So if -4 is here, we need a number slightly to the left, so slightly smaller, so like -4.001, and slightly bigger, like -3.99. And all I'm doing is actually looking at my signs. So yesterday we focused on the infinity and saying, okay, with that, what are my signs doing? So I don't care exactly what the numbers are, but what I'm thinking about is if I plug it in, what's happening on the left side and what's happening on the right side of my, oh my gosh, we're not doing -4, back that train up. All right, we're doing +4, my apologies, I'm so sorry. So we're doing 4 here, so we want to see what's happening on the left of 4 and the right of 4. So a number slightly smaller, 3.99 and 4.01. 001, doesn't matter. Okay, so for my left side, what I'm really doing is thinking about if I plug 3.99 in for every single x, what's happening to the top? Do I have a positive answer, negative answer? What's going on? So if I plug this in, so if I do 2 minus that number, I'd end up with a negative number. I don't care what the negative or the number is, but I care what the sign is. All right, and then on the bottom, let's see, if I plug 3.99 in here and I subtract 4, I'm going to subtract a bigger number, so I'm going to end up with a negative in that parenthesis. And then if I add it here, that's nice and not so bad, I'd be left over with positive. So what you're doing is saying, okay, what are my signs going to be? I end up with a negative over a negative, so ultimately that gives me a positive. And that's going to give me actually a positive infinity. So you're really looking to see, are these going to negative infinity or positive infinity? And that's it. So that's part A, that's the left side. For the right side, I take that number, kind of plug it in and see like, what's the number going to be? So as I'm doing this, I do 4 minus that number, I end up with a negative again. On the bottom here, when I do 4 minus 4, well, I'm subtracting it now and ending up with a positive for this left parenthesis. For the right parenthesis, when I plug it in, I get all positive. So I have a negative over a positive, which ultimately means it's a negative infinity. All right, so on the right side, it's going towards negative infinity. So the right side, this graph is going down here. And on the other side, the graph is going up here. So when you look at that, these are two different numbers. So from the left and from the right, they're going towards different values. So for that number does not exist. Okay, left and right don't match, just like the other ones. All right, a couple more ideas, and then we're done. Flip over to the next page on page 12. All right, we have a couple things to do with infinity. So what if you have a fraction and you're asked to plug in infinity? All right, so what we talked about was yesterday was saying, okay, what really affects this is just the leading term in the leading term. Okay, so I'm really just focused on the leading terms and comparing these and what they do. So you're doing 3 times infinity and you're doing 6 times infinity. So the degrees actually match. It's degree of 1 on top and degree of 1 on bottom. So really, these infinity values are all the same, top and bottom, so they actually cancel each other out. And the only thing I'm really left with that's changing the function is 3, 6. Okay, so when the degrees are the same, we really take the leading coefficients and say, okay, the x's are actually going to cancel each other out, so the infinities cancel each other out. So really, the 3 and the 6 are the only thing that's doing anything, so that leads to 1/2. Now, letter B, when you plug in, what I'm really focused on are these leading terms here. This is not going to affect it very much as these exponents are. So I have 4 times infinity squared, and, oh, sorry, it's a negative infinity. And 4 times negative infinity cubed. Alright, so what this means is that, well, I'm sorry, that's a 2. What is going on? It's a 2 down there. Alright, so the top number compared to the bottom, the top is smaller than the bottom, so you will always have a smaller number divided by a bigger number. So this is like saying something like if you take 1 and divide it by 100, you're very, very close to 0. If you take, even with the negative, if you took it, the negatives affect it. When the top is smaller than the bottom, it's always a smaller number divided by a bigger one, which means it's closer and closer to 0. So when the degree of the top is bigger, no, sorry, back up. Degree of the top is smaller than the degree of the bottom, it always goes towards 0 for the limit. Alright, and then this last one here, when we do infinity here, I'm not worried about. The only thing I'm really worried about are those leading terms. So I have negative 2x to the 4th over x. So really what happens is the top overpowers the bottom. So this, actually thinking about algebra, these simplify to negative 2x to the 3rd. Because these x's kind of cancel each other out. So I have a really, really big number on top. I just got to figure out positive or negative divided by something on bottom. Okay, so it's negative 2 times this to the really, really big number over a big number, just not as big as the top. So we have a negative infinity divided by some other infinity number, and we end up with a negative infinity. So if the sign degrees are equal, take the leading coefficients and simplify. If the top degree is smaller than the bottom, it always tends to go towards 0 because the top will be smaller than the bottom. And when the degree is bigger than the bottom, we always focus on the bottom will affect it, but we need to make sure our signs work out. So we will always just do what we did before and figure out with the exponents. Is it going to be a positive or negative, and just towards infinity. So for Monday, your homework is to work out page 13 and 13 through 15. So homework due Monday, page 13 through 15. See you later. Let me know if you have questions. Bye.